Friends, welcome to the seventh session of a third module in refrigeration and air conditioning system. So, students, we were discussing about some non-conventional refrigeration systems like vapor absorption system (VARs), right? So in the previous class, I have taught you a type of vapor absorption system with aqua ammonia solution as a refrigerant, and I have given an assignment to explain about lithium bromide vapor absorption system. And today I'll be discussing about a special type of vapor absorption system called domestic Electrolux system. Domestic Electrolux. Electrolux system. Actually, this is a three fluid system. Three fluid system. So in the previous section, we have discussed a system which have only two fluids, right? In case of aqua ammonia solution, the water was the the refrigerant was ammonia and water was the absorbent, right? And in lithium bromide, water is the refrigerant and lithium bromide is absorbent. Now we will discuss a special technique called domestic electrolyte system, which have got three fluids as the three working fluids, right? So students, actually this was developed by a company called Electrolux company. You might have heard about Electrolux company, right? So numerous refrigerators in the market are available in the market that produced and manufactured by the Electrolux company, right? So the idea was initially developed by Electrolux company of Luton, England. So have a look at this figure. So this is the vapor absorption system. So you can see here the main purpose of the system is to eliminate pump, right? So you can see here there is an evaporator and a generator, but there is no pump in between evaporator and there is an absorber here. And in the previous type that we have studied, that is aqua ammonia, the vapor absorption system working based on aqua ammonia solution, there was a pump in between absorber and generator, but here you can see there is no pump. Instead there is a heat exchanger, right? Okay, so the main purpose of this system is to eliminate pump, so that in the absence of moving parts, you can reduce the wear and tear and it will become noiseless. So there is no pump here. There are three fluids used in system. What are the three fluids? First one is ammonia, hydrogen gas, and water. Okay, so these three fluids are used here. And because ammonia is the refrigerant, actually ammonia is the refrigerant, the core fluid is ammonia. Ammonia is the real refrigerant used here. And but you know that ammonia being a toxic refrigerant, uh, and since there is no moving parts, due to the absence of moving parts, there will be very little chances for the leakage. So there is no problem of leakage in this case, because there is no compressor or pump. Whenever there is a moving part, the chances of leakages are higher. So even though ammonia is toxic refrigerant, you don't have to worry about that its toxicity, because there is no chances of leakage here. So the food or anything that is stored in the refrigerator space will not be affected by the refrigerant. So that is the advantage of this system. So students, the hydrogen being the another fluid, another gas called hydrogen is used here, because hydrogen is a very light gas. The presence of hydrogen will increase the rate of evaporation of the liquid ammonia, which is passing through the evaporator. So a lighter fluid, a light gas, actually it is the lightest gas. Lightest gas will enable or will increase or will enhance the process of evaporation in the evaporator. So the liquid ammonia will get evaporated easily due to the presence of a lighter gas like hydrogen. Okay, and hydrogen is also non-corrosive and insoluble in water, so there is no such problems. And the water is used as the solvent or the absorbent, right? because water can readily absorb the ammonia. So I will explain the working of the system. You can see that a strong solution of ammonia from the absorber, the strong solution from the absorber, the strong solution of ammonia from the absorber will move through the heat exchanger. Okay, and heat exchanger, and this strong solution is heated in the generator. So in generator, some heat is supplied, and the supplied heat will, by supplying heat using an external source, this strong aqua ammonia solution will be heated. During the heating process, what happens? The ammonia vapors are removed from the solution, and this ammonia vapor will move to the rectifier. Okay, so what is rectifier? It is actually a water separator. So if there is any portion of water present in that ammonia vapor, it will be removed using the rectifier or a water separator, so that the condenser, so that the fluid, the refrigerant entering the condenser does not contain any water vapor. So water vapor will not be carried with the ammonia vapor, so that dry ammonia vapors are supplied to the condenser. Okay, so these water vapors, if not removed, what happens? They will enter into the what? They will enter into the expansion valve, and subsequently it will reach evaporator. So water vapor will reach the evaporator, and in evaporator, when it is there will be chance of freezing and choking of the machine. So that will be a problem, right? So in order to avoid that, we are using a rectifier in between generator and condenser. Okay, so the hot weak solution left behind the generator. So after heating, the ammonia vapor enters the rectifier, and some weak solution will be left in the generator, which moves. What happens to that weak solution? This hot weak solution will pass through the heat exchanger, right? While passing through the heat exchanger, what will happen? It gets cooled. Why? Because it transfers heat to the strong solution that is coming from the absorber. So heat is transferred from this weak solution to strong solution. So the strong solution will be heated even before it is reaching the generator. So heat removed by the weak solution is utilized in raising the temperature of the strong solution passing through the heat exchanger. In this way, the absorption is accelerated, right? The absorption is accelerated and improving the performance of the plant, improving the performance of the system is achieved. Okay. The ammonia vapors in the condenser, what happens to the ammonia vapors in the condenser? It is condensed using some external cooling source, or directly rejecting heat in the atmosphere. The liquid and it will become in liquid form. This flows liquid ammonia flows to the evaporator. Actually, this process of flowing flows under gravity. So flow takes place under gravity. Flow takes place under under gravity. So that is why there is no usage of pump or compressor. This takes place merely due to the effect of gravity. So flows under gravity to the evaporator, where it meets the hydrogen gas. So here you can see hydrogen is supplied, right? So what is the function of hydrogen? What is the function of hydrogen? Actually, this hydrogen is a very light gas, so the presence of hydrogen will increase the process of evaporation, right? The hydrogen gas which is being fed to the evaporator, permit the liquid ammonia to evaporate at a low pressure. So evaporation takes place. Evaporation takes place at a lower pressure due to the presence of hydrogen. So why that's happening? Because you know the Dalton's principle, right? The hydrogen during the process of evaporation, the ammonia absorbs latent heat from the refrigerated space and thus produces cooling effect. So what is Dalton's principle? Because the total pressure will be the sum of partial pressure of hydrogen and ammonia, right? So the presence of liquid ammonia will decrease the pressure of the what the ammonia, right? Ammonia will be present at a lower pressure, means it will have a lower the boiling point at a lower temperature. So the process of evaporation gets enhanced, right? The mixture of ammonia vapor and hydrogen is passed through the absorber, where ammonia is absorbed in water while the hydrogen rises to the top and flows back to the evaporator. So this completes the cycle. Okay. So this is the working of uh, what Electrolux system. So Electrolux system consists of three fluids: hydrogen, ammonia, and water. Hydrogen is a gas which is used to enhance the process of evaporation, and ammonia is the refrigerant, and water is the absorbent. Okay. So how can you calculate the COP? COP is nothing but an energy or heat energy, heat absorbed in the evaporator to the heat supplied in the generator. The ratio of heat absorbed to the ratio to the heat supplied in the generator. Okay, so you have to note that the hydrogen only circulates from absorber to the evaporator and back. Okay, the hydrogen is limited to this space only, so that point you have to remember. Okay, the whole cycle is carried out entirely by gravity flow of the refrigerant. Okay, so actually the whole cycle is working based on the gravity flow. So there is no external source or external agency or external mechanism to initiate the flow. Okay, this only happens with the help of evaporator. Okay, so this system cannot be used for industrial purposes, as the COP of this system is very low. Okay, so that is why it is not used in many variety of purposes. So because its COP is very low. So students, now we will move to the final topic of this particular module. Steam jet refrigeration is a kind of unconventional refrigeration system. It is also known as ejector refrigeration. Okay, so it has got another name called ejector refrigeration. So we will move to the working of this system. So you can see here the basic principle of the basic principle of a boiling of liquid at lower temperature is by how. So if you reduce the pressure of a liquid, you can boil that particular liquid at a lower temperature. That idea you know, right? So reducing the pressure on its surface, pressure on the surface of the liquid means you can boil that liquid at a lower temperature, right? So the reduced pressure on the surface of water is in this process is maintained by throttling the steam through jets or nozzles. So you can see that a nozzle is present here. So students, you know the working of nozzle, right? You're studying the CFFs. Okay, so nozzle is basically an expander, right? So it decreases the pressure, okay, by increasing the velocity, right? So reduce pressure on the surface of water. So you can see here the chilled water. I will explain the working, but before that, just giving an idea that actually we are reducing the pressure of the water so that we can boil the refrigerant, the water at a lower pressure. So how this reduced pressure is maintained at the surface of water? By throttling the steam through jets or nozzles. Students, when chilled water from the flash chamber, so you can see here chilled water flash chamber is directly used in the form of spray for cooling air. uh, it is called open cooling system. Okay, so there are basically two types of system: open cooling system and closed cooling system. Okay, so when chilled water from the flash chamber is directly used in form of spray for cooling the air. If this chilled water is directly used, it is called open system. When it is passed through coils and it doesn't come in contact with the air to be cooled. So our aim is to cool some atmosphere, so ambient space, or cool some space, right? So if the chilled water is if the chilled water directly comes in contact with that air of that space, it means open cooling system. When it is not in contact with the air directly, it is passed through some coils, then such system is called closed cooling system. So that is the difference between open cooling system and closed cooling system. Okay, now I will explain the working of the system. Okay, so you can see a flash chamber or evaporator. Actually this is the evaporator. Okay, so here so this evaporator is heavily insulated here. Okay, so it is fitted with some perforated pipes for spraying the water. So some pipes, perforated pipes are there which sprays the water. Okay, so the warm water, so here is the refrigerator space. Okay, now the chilled water passes through the refrigerator space. It will absorb heat and it will become warm water, right? So the warm water coming out of the refrigerator space is sprayed into the is okay, you can see that the warm water coming from the refrigerator space is sprayed. You can see that sprayed into the flash chamber. So where some of which is converted, the sprayed water, when the water is sprayed, some of the the water will be converted into vapors after absorbing the latent heat. Thereby, so somehow this chilled water sprayed will get transferred, get converted into vapor. So how, so in order to get converted into vapor, it should absorb some latent heat, right? So it will absorb latent heat from this water here. So this water will get cooled, right, chilled. So this chilled water is again fed to the refrigerator space. So students, the high pressure steam from the boiler, we have a boiler here. High pressure steam from this boiler is passed through the steam nozzles. A nozzle, as it gets expanded, thereby increasing its velocity. Okay, the high velocity steam in the ejector would entrain or capture the water vapors from the flash chamber. So this high speed steam is coming through the nozzle and get ejected into the ejector, and the ejector will entrain the water vapor coming from the flash chamber, which would result in the further formation of vapor. So the vapor formation gets enhanced while because a ejector is placed here. Okay, so the mixture of the steam and the vapors here, passes through this venturi tube of the ejector and gets compressed. While it is passed through the ejector, it gets compressed and then it will move to the condenser. The temperature and the pressure of the mixture gets raised here, and when it moves through the condenser, it will be a water cooled condenser. So what happens, it gets condensed means its temperature will get reduced and it will become in liquid form. This condensate is again fed to the boiler. So this condensate is again fed to the okay, here after condensation, this is cooling water coming and out. The condensate, the vapor which got condensed will again move to the boiler and the process again repeats. So what is the advantage of this process? Because while it is getting ejected here, while it is getting ejected, this nose, this high pressure nozzle is getting ejected, means somehow the pressure here gets reduced because it is getting rejected. The expansion is taking place, the pressure gets reduced and the vapor formation is enhanced because the boiling point is reduced. So that is the advantage of this particular system. Generally 1% of evaporation here in this flash chamber is sufficient to decrease the temperature of chilled water to up to 6 degrees Celsius and all. Just 1% of evaporation, 1% of evaporation here, 1% of evaporation of the water will enable or enables the system to reduce the temperature of that chilled water up to 6 degrees Celsius. Okay, so that much is the effectiveness of this particular system. So with this, I hope you have understood the process, the working of this particular system, and you can read much more about this particular system in your textbooks and all, so that you can get a better idea. So you may be, so if you read the textbooks, you will get a better idea about this ejector and why this, or some Venturi effect of this, and this the converging diverging nozzle to convert the pressure energy of a motive fluid to velocity energy. Okay, that kind of extra information will be available if you read the textbook and all. So in the exam point of view, you just need to know the working of the system. That's all. Hope you have understood these two systems, Electrolux and what Electrolux and this steam refrigeration system. So with this, I conclude my third module, and in the next class onward, we will start with the fourth module. Thank you.